If I was traveling alongside one of the Voyager probes, would there be enough light to see it? And if so, how far would I need to be from the sun before I couldn't really see it? I'll take the follow-up question: how far would I need to be from the sun before I couldn't really see it? No such place, or at least, Voyager will never get there. Once your eyes adjust, you can totally see things by starlight on Earth on a moonless night with no light pollution. Thus, even if you're so far from the sun that it's just another star in the galactic sky, you'll still be able to see Voyager. If you were outside the galaxy, I'm not sure whether there'd be enough light to see, but Voyager is highly unlikely to ever get that far even after 1 billion years. The brightness of the sun just outside our atmosphere is 1360 watts per square meter. We are around 100 million kilometers 100 million from the sun, and the Voyager probes are around 14 billion kilometers 14 billion away. Using the inverse square law, that works out at around 6.95 watts M2 0.0695 Wm2. That's actually pretty bright considering the distance. I am wondering if I messed up the calc. Also awesome question. Edit: I messed up the calc. Thanks you Cryptotope. If you were far enough away from the sun that it appeared as just another star, you'd still be able to see the probe. Not well, but you can see by starlight. And of course you would see the stars, and its silhouette blocking them. The sun's luminosity is about 41026 W, and Voyager 2 is around 12 billion km from the sun, working out to a total flux at Voyager 2 of 0.24 watts M2. A quick search on Google says the minimum flux of light that can be picked up by the human eye is around 1010 Wm2. So you should still be able to see it. The distance at which light flux reaches 1010 Wm2 works out to about 610-17 meters, or about 63 light-years. Side question. If you could withstand all the ways space could kill you, and you traveled alongside the Voyager, would the heat kill you? I've seen that it's almost 300 degrees on the sunny side of the moon. So without an atmosphere, nearly any sun exposure would cook you, yes. What these answers have taught me, is that in sci-fi shows and movies, when we see a well-lit ship in space, it's usually accurate. I say usually because most of the time a ship is shown, it's in one star system or another. Cool. The light wouldn't be the issue, as others have said, even that far from the sun there's still plenty of light. A bigger issue would be that unless you're pretty close to it, it might be difficult to spot it, because space is pretty big and you could very easily miss it. Also, the Voyager itself doesn't emit any light, and the only light that far out is the light that comes from the sun, unlike on Earth where there's a ton of reflected light. Point is, if you're not in a position, and again, space is pretty big, to see the light the Voyager reflects or directly on its shadow, you might not see it. The short answer is yes, the dark adapted human eye can respond to a single photon and the local universe is stuffed with those things. The longer answer is that we revert to ancient Greek thinking: on sight our eyes send out light and we see the reflection. So we have radar, and sonar and such. Our spaceships will scan the local environment just like a battleship.